Hey y'all, today we are going to divide monomials. And to divide monomials, we're going to use the quotient rule. Now before I go ahead and actually tell you what the quotient rule is, let's see if y'all can figure it out. So let's look at our first question and then we'll come back to the actual rule. All right, so find each quotient. Quotient means to divide. So x to the fifth divided by x to the third. X to the fifth means I have how many x's? I have 5 of them. If I multiply those 5 together, that's where I got x to the fifth. X to the third means I have 3 x's. If I multiply those 3 x's together, that's where I got x to the third. Think about this. Anything divided by itself is 1. So this divided by itself is 1. This divided by itself is 1. This divided by itself is 1. 1 times 1 times 1 is just 1. Do I necessarily have to have that 1 in front of the variable? No. How many x's am I left with? I'm left with 2. So 1x squared or just x squared. How do you think? So I actually showed it out. I did expanded form to show what that x to the fifth means, what that x to the third means. And then I just used my basic knowledge of division. Anything divided by itself is 1. I had 3 things cancel out and I was left with 2. How do you think looking at that problem, I got this x squared? Think about that. We'll try one more and then we'll see. K12 means I have 12 k's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Divided by K2 means I have 2 Ks. All right. Anything divided by itself, so I need to use that. Anything divided by itself is 1. Anything divided by itself is 1. 1 times 1 is 1. How many Ks am I left with in the numerator? Looks to me like I am left with 10 Ks. So 1 K to the 10th, or you could just leave it as K to the 10th. Any thoughts on how I got that instead of writing it out in expanded form? I'm sure some of you are thinking it. You subtract. So K to the 12 divided by K squared, 12 minus 2 is 10. Same thing up top in this first one. K to the fifth divided by K to the third. Or sorry, x. X to the fifth divided by x to the third. 5 minus 3 is 2. So the rule is you subtract your exponents, whatever they may be. So when we multiplied, we added them if we were just multiplying. Yesterday, we learned power to a power where you had to actually multiply the exponents. That's a little different situation. So when we multiply, we add the exponents. When we divide, we subtract the exponents. All right, let me get some of this out of here so I can look at this next one. I'm going to show you this next one in two different ways. So m to the third divided by m to the third. Well, in the numerator, m to the third means I have 3 m's. In the denominator, m to the third means I have 3 m's. Remember, anything divided by itself is 1. Anything divided by itself is 1. Anything divided by itself is 1. I'm literally just left with 1 times 1 times 1, which is 1. All right, let's look at it actually using the rule. Okay? When we're dividing like basis, we keep that base and we subtract the exponents. Well, 3 minus 3 is 0. Anything to the 0 power equals 1. Anything. This is the 0 power rule. Anything raised to the 0 power equals 1. Okay? This kind of explains it a little bit better, but if you want to look at it this way and do the subtraction rule, you just have to remember, don't leave it as m to the 0. You've got to know anything to the 0 power equals 1. All right, let's look if we have a little bit more more variables going on here. So we got A's and B's. So a to the 6 divided by a squared. So 6 minus 2, which would be 4. B to the 4th divided by b to the 3rd. Subtract those exponents. 4 minus 3 would be b to the 1st. So a to the 4th, b to the 1st. Could you very well do exactly like I showed you if you like that better and do 6 A's, 4 B's? If you prefer this and that helps you to see it better, you are more than welcome. I just recommend that you line things up like that, and then anything divided by itself is 1. I'm left with 4 A's. Anything divided by itself is 1, and I'm left with 1B. Exactly what I have there. So it's really your choice. It just depends on what you prefer. All right, P's with P's, Q's with Q's. So 7 minus 4 gives me P to the 3rd. Q to the 16 minus 12 gives me Q to the 4th. All right, now it looks to me like this Z doesn't have an exponent, so put a 1 there so you don't make a silly mistake. I've been telling you that from the beginning. So X is with X's, Y is with Y, Z is with the Z's. So X to the 20 minus 5 should be X to the 15th. Y to the 9 minus 9, which is Y to the 0. Anything to the 0 power is just 1. And Z to the 2 minus 1 is just Z to the 1st. So really, that is just 1x to the 15th, Z to the 1st. Do I have to have this 1 in front of it? No. I could just have x to the 15th, Z to the 1st. So don't always think that if anything to the 0 power just cancels. It cancels to 1. And in this situation, I don't have to have the 1 in front of it. But if this was the only thing in my question, I most certainly would have to have that 1. So just be cautious on that. All right, let's get a little harder. Let's throw some coefficients in there. So if I throw some coefficients in there, you're going to divide the coefficients just like you would normally. And then you're going to simplify the variables using the quotient rule. Okay, so the coefficients get divided like normal. 6 divided by 2 is 3. X to the 4th divided by x to the 3rd. I subtract those exponents, and that gives me 3x to the 1st, or just 3x. Either way is acceptable. We do need to be cautious because sometimes if I try to divide my coefficients, sometimes they may not divide evenly and they may have to be left as a fraction. So don't ever change them to a decimal. You can leave them as a fraction if they don't divide evenly. All right, coefficients first. 14 divided by 7 is 2. I'm going to put 1s on that R and that S so I know. R squared minus R1, S squared minus S1. So that gives me 2R to the 1st, S to the 1st, or just 2RS. Either way. Coefficients get divided. So negative 36 divided by 4 would be negative 9. C's with C's, D's with D's. So C squared minus the squared, that would give me C to the 0. Anything to the 0 power is 1. So just this part turns to 1. D to the 5th minus D to the 3rd would give me D squared. So technically, if I finish this out, negative 9 times 1 is negative 9, and then I just have my D squared. All right, let me get a drink. Coefficients with coefficients, and they get divided. You do what it says. Negative 15 divided by negative 3. A negative divided by a negative is a positive. I'm going to add a 1 on the Z. x6 divided by x5, so 6 minus 5. y5 divided by y3. And does that z have anything to go with it? It doesn't, so just leave it. Now let's see if we can go further here. I just showed my work there. So what is that? x1, y2, z1? Which could also be written as 5x, y2, z. Either one is acceptable. All right, number 11, you do need to be a little bit cautious here because 4 divided by 8, my coefficients there, that doesn't divide evenly. When your numerator, your number on the top, your numerator is smaller than your denominator, it's going to have to be left as a fraction. So 4/8 reduces to 1/2. N to the first divided by n to the fifth. When I divide like basis, I subtract. So that gives me 1/2 n to the fourth. So the coefficient is 1/2, and then n to the fourth is on the side. All right, 36 divided by 54. It doesn't look like, I don't think that's going to divide evenly either. I think I'm going to have to leave that as a fraction because my numerator, my 36, is smaller than my denominator. So what is 9? 9 divides into each one of those, right? So 9 goes into here 4 times, and 9 goes into here 6 times. Actually, can I keep reducing this? 2 goes into 4 twice. 2 goes into 6 3 times. So that reduces to 2/3. M's with M's. So M to the 9 minus 3. And N's with N's. N to the 5 minus 2. So 2/3. M to the 6th. N to the 3rd. So just be cautious there. Sometimes when your coefficients divide to make a fraction, that is fine. You can still have that. All right, let's go one step harder where I'm kind of throwing in some rules that we learned last week and Monday into you as well. Okay, so we're going to kind of mix it all up here. So if you look at what I got in number 13, I need to be really cautious in number 13 because it looks to me like I have some parentheses that have an exponent. And remember, we did this yesterday, okay? Everything, so I have to get rid of the parentheses and the exponent first before I can do division. Think about your PEMDAS, your order of operations. Parentheses and exponent come before your multiplication or your division, okay? So everything in here is being raised to the second power. So 3 gets raised to the second power, and x to the 5th gets raised to the second power. The denominator is just staying as this. Looks to me like I need to keep cleaning up that numerator. So 3 squared, y'all know, is 9. When I raise a base from one power to another, I multiply those exponents. That's what you learned yesterday. So x to the 10th. And then that denominator stays the way it is. So I cleaned up that numerator, and now it looks to me like I just have division here. So 9 divided by 27. What, 9 goes into 9 once, 9 goes into 27 3 times, so that would be 1/3. It does not divide evenly. x10 divided by x3. I keep the base when I'm dividing and subtract those exponents. So 1/3 x to the 7th. So not much harder, but they're just throwing a couple extra rules in that for you. So just be cautious there. All right, what about, let's skip 14. Let's go to 15. Oops. All right, what about if I throw something at you like 15, where in this situation, I am raising the denominator to a power. Okay, so I'm leaving that numerator. I'm not doing anything to that yet. I got to get rid of these exponents and that parentheses and the exponents in the denominator. That W and that V get a 1. So remember, everything inside of these parentheses are being squared. So 4 squared, W1 squared, V1 squared. I cannot touch that numerator until I finish cleaning up that denominator. So 4 squared is 16. W to the first raised to the second power. When I take it from one power to the next, I multiply. So 1 times 2 is 2. Again, a power to another power, multiply. So now that I've cleaned up that whole denominator, now it looks like all I'm left with is division. So 12 divided by 16. What, 4 goes into this 3 times and 4 goes into here 4 times? So it reduces to 3/4. I can't go any further there. W's with W's, so W to the 9th, and I subtract. And V's with V's, and I subtract because I'm dividing like basis. So what would that be? 3/4 W to the 7th V squared. So not really difficult, but it is really, really important. And I've been stressing this for a long time. It's important. Show your steps here, y'all. Don't skip all this, okay? It's not a lot, but I promise you, it's going to help you in the long run. So take your time on that. All right, so now, number 16. So 16 is kind of incorporating a little bit of what we did in 13 and 14. 16 is asking you to raise everything in the numerator to the 4th power and everything in the denominator to the 2nd power. Because I got to get rid of those parentheses and those exponents first. So I do have to do a little bit more work here. So everything in the numerator gets raised to the 4th power. So 2 to the 4th. C to the 1st to the 4th. D to the 4th to the 4th. Everything in the numerator gets raised to the 4th, and everything in the denominator gets raised to the 2nd. So this is just me showing my work so I don't make any silly mistakes. All right, now I'm going to finish cleaning up that numerator. So 2 to the 4th power. What's that? 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. C to the 1st raised to the 4th power, I multiply, so that's C to the 4th. D to the 4th raised to the 4th power, it's a power to a power, multiply, so that's D to the 16th. All right, I cleaned up that whole entire numerator. Now let's clean up that denominator. 2 squared, just 2 times 2, which is 4. C squared raised to the 2nd power, a power to another power, I multiply, so C to the 4th. And D to the 3rd raised to the 2nd power, power to a power, I multiply. So 3 times 2 gives me what, 6? All right, so I fully cleaned up that numerator, I fully cleaned up that denominator. Let's see if I can actually do my division. 16 divided by 4 is 4. C's with C's, D's with D's. So if I subtract, doesn't that give me C to the 0? And anything to the 0 power is just 1. If I subtract with these, that gives me D to the 10th. So technically, 4 times this 1 here would just be 4 D to the 10th. All right, let's try one more together, and then I'll let you know what you're going to have to do. Let's go to 17, right on the back there. And remember, then you're going to take pictures of these notes that we did together and the problems that you have to do on your own. Okay? All right, be really careful on this one because it is raising everything to the 3rd power. That means everything in the numerator gets raised to the 3rd power, and everything in the denominator gets raised to the 3rd power. So I'm just going to show what that means. Every single thing in the numerator gets raised to the 3rd power. Every single thing in the denominator gets raised to the 3rd power. So I'm kind of separating it so you can see. And then I need to go one step further. Everything in the numerator gets raised to that power. Don't skip these steps. Everything in the denominator gets raised to the third power. I added a 1 on that end, notice that, so be careful. All right, so now I can kind of finish cleaning up that numerator. I'm just going to go over here. 2 cubed, 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. When I raise something from one power to another, I multiply, so that's m12. And then power to a power, I multiply, n6. So I cleaned up that numerator. Now let's clean up that denominator. 4 to the third. Do not, some people make really silly mistake on that, and they'll say 4 times 3 is 12. No. Yes, 4 times 3 is 12, but that's not what that tells you to do. When you raise something to a power, it means that thing, that base, times itself that number of times. So that's why I like to show it out. 4 times 4 is 16. 16 times 4 is 64. M2 raised to the third power, so if I multiply, I get M6. And 1 raised to the third power, if I multiply, I get n to the third. So cleaned up the whole numerator, cleaned up the whole denominator. Now I'm ready to finish my division. That's all I'm left with. Follow that order of operations, that PEMDAS, parentheses, exponents, multiplication if you have it, and then your division. So 8 divided by 64. I don't think that divides evenly because my numerator is smaller than my denominator. So 8 divided by 8 is 1. 8 divided by 64 is 8. You're always thinking, what number goes into this numerator and this denominator? That helps me simplify. So it simplifies to 1/8. If I'm dividing like basis, I subtract. So 12 minus 6 is 6. 6 minus 3 is 3. So 1/8, m to the 6th, n to the 3rd. So again, it looks like a lot of work, but it's not. It's just helping me take it step by step so I can see what I am doing wrong. And I think y'all understand by now that you don't show your work, you're not going to get credit. All right, so be careful on your packet because after the dividing notes, I think, let me just get to the dividing notes really quick. After the dividing notes, on that, skip those 2. And then the next page, you should see homework 3, monomials. I want you to go to that. All right, so homework 3, dividing monomials, the problems you're going to do on your own, and then you're going to take pictures of everything we did together and everything you did on your own. Circle these. 1, 2, 3, 5. Next one is 7 and 8. And then 13, 14, and 18. So that's 9 questions. And then at the end, when you upload your pictures, you should have 3 sheets. This one sheet from homework 3, and then there should be 2 pictures from the notes I did with you because some problems were on one page and one problem was on the other. So you should be uploading 3 pictures, nice, clear pictures. Y'all been doing good at that. If you have any questions, let me know. Keep working hard. Thanks.